So, good evening. My name is Lisette Batiste, and today I'm presenting my capstone on an explainable AI framework for early autism screenings. And this is a pilot study. My mentor on this capstone project was Dr. Ashma, and this serves as a foundation for my future doctoral research. In terms of my agenda, I'll begin with the problem, the solution, and key contributions of this research. And then I will move through my motivation, methodology, and system design. I'll close with results, challenges, future work ethics, and a final summary. And then I'll pause for any questions. So my executive summary has quite a bit of information because I wanted to be as detailed as possible. So I have some information here on my problem statement, background, key contributions, my overall hypotheses and methodology, and etc. And the main goal for this slide was not to regurgitate all of this information to you guys during this time, but that this PowerPoint presentation could be used as a tool where this slide could be taken out and used and ingested at later times. But the main thing that I want to summarize here that I believe is the most important is that autism screening today is often delayed and inconsistent. So I wanted to use my research to develop a hybrid AI model, which combines structured behavioral data with Dilbert embeddings. And the key contribution is an explainable framework, which aligns with DSM-5, and it produces interpretable screening outputs. And my hypothesis is that combining text and structured data overall improves both accuracy and clinical interpretability. And I will show you some more of my solutions later on in this presentation, as well as talk through some cybersecurity risks and consideration. And the main two research questions that I wanted to answer would be, does incorporating text-based embeddings improve predictive performance compared to structured data alone? And then secondly, how does the hybrid approach perform across different data sets in terms of accuracy, fairness, and the overall generalization of this research? So let's talk a little bit about my motivation. In summary, you see two graphs in front of you. All these mean is that autism has been tracked at least since the late 1980s. And as you can see, the cascade of results from then up until 2024, you can see that the rates are going up by the thousands. And then if we look individually at cases of adolescents or children in general, and we look at ratios, in early 2004, we were looking at about 1 in 166 kids. And as early as 2020, we were at 1 in 54. And then an additional research fact that I actually learned a few days ago is that 1 in 30 Black children are autistic. And so I think it's important to look at numbers like that. And so early detection of autism, it significantly improves long-term developmental outcomes. And our current methods rely heavily on subjective observation. These approaches overall lead to delays, inconsistencies, and unequal access to care. And so this creates a need for a strong, scalable, data-driven screening solution, which is what I aim to do in this study. Wanted to share a proof of concept. This is a later slide that I added. It essentially is the antithesis of my capstone and my future PhD work. On the right side here, I have a couple of articles that Dr. Ashman kindly shared with me. And I'll use these to dive deeper since this is a pilot study for me. But overall, some key takeaways from looking at the Dilbert and small language models is that Dilbert is a smaller, faster version of BERT. It still retains strong performance while reducing computational costs, so that's a great benefit. And then it allows us to extract contextual meaning from behavioral descriptions efficiently. And lastly, it makes for ideal scalable real-world screening applications. Talking a little bit about related work. So as I mentioned already, since traditional screening methods are subjective and they're difficult to scale, we can use machine learning to increase interpretability The only issue there is that sometimes it can limit clinical trust. So we have to work in tandem with clinicians in order to safely and efficiently use data in order to gather results that are needed to build machine learning models. And then at times there can be a gap in combining structured behavioral data with language-based insights. And so my method for this approach in using the models that I did was to hope that it would address some oversights in that area. Looking a little bit at my objectives, my overall goal is to build a hybrid model that integrates structured data with language embeddings. And I wanted to align that output with DSM-5 domains. You can see on the right side here the difference of classification between DSM-4 and DSM-5. Another objective was to improve interpretability compared to just traditional machine learning approaches. I wanted to use more robust difficult models. I'll talk a little bit further down about some difficulties around using Dilbert, especially because it was a new machine learning model for me. But I wanted to challenge myself and use a model that I had not used before. And then finally, I wanted to evaluate my performance and scalability for a real-world screening application. Very quickly, my design methodology, my approach. I designed a hybrid explainable AI framework. It combined structured behavioral data with language models. My approach improves semantic understanding while reducing the subjectivity in my screening. And a key focus throughout was to maintain clinical interpretability. A little bit about my method. So my pipeline started with collecting my data, then I did my pre-processing. I followed that by feature engineering and text transformation. I then used my hybrid data set to train the model and generate predictions. And then my final output was a structured interpretable screening result, which I'll show you in just a bit. Touching very quickly on my data structure. So my data set combines structural behavioral features with Dilbert generated embeddings. The synthetic behavioral narratives are created to enable text processing. And then finally, the data set was clean, balanced, and ready for modeling. So talking a little bit about my data gathering. So all of my data came from a Kaggle autism screening data set. It had both behavioral and demographic variables. It included label outcomes, making it suitable for supervised learning. And while it was useful, it did have some limitations in clinical depth and diversity. And I'll touch on that a little bit more in my presentation about how I will overcome some of those issues when I continue this study in my PhD. So data gathering. So again, this is just showing how everything was pre-processed, how I put it together for the model, and how I prepared all of my data for training. I did a stratified train test split. This helped me to preserve my class distribution, and it helped me to also balance my data set because I wanted to make sure there wasn't a class imbalance in my data. And then finally, my data set was structured for integration into a hybrid machine learning pipeline. Very quickly, these are the features in my data set. Very traditional, as you can see, A1 to A10 were my behavioral screening response questions. A binary answer, yes, no, and then age, gender, etc. in terms of really kind of defining those data sets as much as possible. And then I had 4 indicators: limited eye contact, delayed speech, repetitive behavior, and poor social interaction. And I had a scoring on all of those. And I was essentially looking for anything above 50%. Now to share a little bit about my results that I have here for my small language model and my analyses as well. Excuse me. My model overall achieved a strong performance with an 87% accuracy and an ROC AUC of 0.91. My precision and recall are well balanced, with recall slightly higher, which is important for screening use cases. And overall, the model effectively identified at-risk cases while maintaining low error rates, which was very important. Had 6 different breakouts of the data, as you can see here, the confusion matrix, my SHAP, my Dilbert embedding coefficients, which I'll talk a little bit more about in my next slide, my embedding values for my Dilbert model, my precision recall curve, and my ROC curve, both for my Dilbert as well. My design and methodology, the tools and technologies that I used, very simple front-end visualization. I did some Tableau and Power BI and Streamlit as well. I didn't necessarily use everything for this particular presentation because of the interest of time and because we're limited in how much we can show in this PowerPoint, but I likely will pull some additional graphs and charts from there for my paper, and then for my backend modeling application, Python, of course, the Dilbert SHAP, which I showed earlier. I had my Kaggle dataset and CSV, and I did do some memory data processing in Pandas, though it's not reflective in this presentation, but might be in my paper. Almost at the end here, highlights and challenges. This research produced a full end-to-end hybrid model with explainability built into the overall framework. It successfully combined structured and text-based data for improved screening insights. Some of my challenges were that my data set was limited. I wish it was a little bit more robust. I had some integration complexity, and I had a little bit of issue with balancing accuracy and fairness and interpretability in the beginning, though I was able to scale that in the end. Future work. So I'd like to continue validating my models, building new models and expanding on them. I would love to get my hands on some real clinical data and conduct some pilot studies based off of that, all HIPAA compliance, of course, AI compliant, of course. And I do believe that there is a potential to expand into multimodal data, such as speech and video, which for autism is very great because it gives a lot more insight. And exploring additional transformer models, I think, can help to further improve performance and the overall generalization of this research. I just wanted to talk very quickly about some ethical considerations. So since autism data is highly sensitive, privacy and data protection is very critical. There also is a risk of bias if the data sets are not representative. And my model was intended as a screening support tool, not a diagnostic system, and it would require some clinical oversight. But I do feel like being HIPAA compliant while using the data and model building would be helpful in using this research and data to turn it into a cloud-based tool that could help clinical researchers and clinicians overall. In summary and in conclusion, my research demonstrated that hybrid models can improve autism screening by combining structured and language data. It can deliver strong performance while maintaining interpretability through DSM-5 alignment, and it also established a foundation for future clinical validation and real-world deployment. I do feel like this is research that can grow in other ways, and it can be used to partner with other research departments, hospitals, clinicians, and private practice companies as well. Here are my references for my study, both for my PowerPoint and my paper. Thank you for your time and attention, and I welcome any questions or feedback.